All right, which value of x satisfies the equation? So once again, you could try plugging it into the equation, each of these values, to see which one gives you 16, or you could actually solve it. Me, old-fashioned way, I'm gonna solve it. So first rule, do I have distributive property? Yes, I do. So there's two ways in which I can do this, and I think I'm gonna show you both ways. So distributive property, so then 5 over 6 times 3 over 8 is the same thing as 15 over 48. Okay, when you multiply fractions, you multiply the top and the bottom. 5 times 3, 15, 6 times 8, 48, and then minus 5 over 6 x. Okay, you distribute it, and that should equal 16. The next one, do I have fractions? Yes, I do. Let's turn 16 as 16 over 1, so for the sake of doing it. So what to do if we have fractions? Well, multiply the whole equation by the common denominator. Now, what is the common denominator in this case? Correct. Between 48 and 6. Can 6 be multiplied by a number to get 48? Yes. So then, we have 48 as your common denominator. So multiply the whole equation by the common denominator. Okay, I could multiply 48 by 15 and then divide by 48, but I don't even know what 48 times 15 is. So it's easier for me to divide first and then multiply. Look, 48 divided by 48, 1 times 15, 15. 48 divided by 6 is 8 times 5, 40. And now 16 times 48 is a hassle, so I'm gonna have to use the calculator. Okay, and now the next rule, do I have variables on both sides? No. Do I have additive inverse? Yes. Look, 15 is being added, not subtracted. The sign to the left is what determines whether it's been added or subtracted. So 15 is being added to negative 40x. So to get rid of it, I'm going to subtract. I'm going to use the additive inverse. So now I have negative 40x equaling, what is 768 minus 15? Okay, 753. And now I'm going to divide by negative 40. Okay, what's the last rule? Multiplicative inverse. So I would multiply by the multiplicative inverse of negative 40, which is 1 over negative 40. Or, since we are at this level right now, after so many episodes, you could just divide by negative 40 on both sides. All right? And what do you get? You get x being equal to negative 18.825. Okay? And now we go and select our choice. Correct choice is number 2. See that? Okay. Let us, oh, by the way, if I had done it on the calculator, would I have gotten the same thing? Let's try it. Only those of you who have this calculator, good job. If you don't, then too bad. So press math. And there you have it. Solving equations the easy way. Alright, let's move on to the next one. And always remember, pause the video, try the problem out and compare your answer to mine. Don't just wait for me to give you the answer, because then, I mean, it's learning still, but not at its peak. Alright, so the solution to this equation. The first thing I have to ask myself is there distributive property? And I see that there is. So 4 times x is 4x minus 28 equaling to 0.3 x, distributive property, plus, okay, what is 0.3 times 2? Beautiful, that's 0.6. And then plus 2.11. All right, the next rule is, are there any fractions? No, there are no fractions. The next rule is, are there like terms on the same side of the equation? Yes, there are. The 0.6 and the 2.11. So we just add them. What is 0.6 plus 2.11? Good job. So then we have 4x minus 28 equaling to 0.3x, okay, plus 2.71. Now the next rule. Do I have variables on both sides? Yes, I do. So I'm going to get rid of the variable that has the lesser value. In this case, 0.03x. So I'm going to subtract 0.03x, okay? And then minus 0.03x. Now listen, if you know another method of solving these equations, then by all means use it as long as you get the right answer. Alright, so what is 4 minus 0.3? That's 3.7. So we have 3.7x, okay, minus 28 equaling to 2.71. Alright, so we did variables on both sides. Now the next rule says, do we have additive inverse? Of course, negative 28, so I'm going to use positive 28 to get rid of it. Okay, so now what is 2.71 plus 28? Tell me. Exactly. So we bring down the 3.7x, this canceled out, equaling to 30.71. And now we're going to divide by 3.7 on both sides. Notice that I'm not using the multiplicative inverse method anymore. I'm just dividing, but you know that that's exactly what I'm doing. Oh, okay. So now what is that?
Mama.
8.3. And now we'll go back to our choices, and choice number 1 is the correct answer. Remember, you have distributive property, so you use the distributive property. 2 over 12 x, 2 times negative 2 is negative 4 over 3. Or look, negative 2 times 2 is negative 4 over 3. Same thing. Equals, and now here, on top I get 4, and the bottom I get 15, x minus, anything times 1 is itself, so minus 1/5. Okay? And now, the next rule, what is the second rule? Do I have fractions? Yes, so multiply everything by the common denominator. What is the common denominator? I have no idea. I have the numbers 12, 3, and 15, and 5. Okay, I know that 3 goes into 12. I know that 5 goes into 15. So how am I going to get rid of all these variables? 12 and 15. Is there a number that 12 and 15 have in common in the times tables? Definitely, I could tell you that I'm going to have to do it by hand. Now, how do I do this by hand? Can I do it on the calculator? Yes. Do I know how to do it? I don't remember. I'll find out. All right, so on an index card, I'm going to take my denominators. 12, 3, 15, and 5. And I'm going to play the game down to 1. So what is the lowest number I can divide by? I can divide by 3. Actually, you know what? It's not true at all. I can divide by 2. Never try to divide by 1 because you're never going to end the game. The lowest number you can divide by is always going to be either 2. You start at 2. And then if not, then 3, then 4, never 1. So let's see now. 5 cannot be divided by 2, so it stays at 5. 15 cannot be divided by 2, stays at 15. 3 cannot be divided by 2, stays at 3. 12 divided by 2 is 6. Oh, okay. Now, what is the lowest number I can divide by? Well, I can divide by 2 again, and this remains the same, but now 6 becomes a 3. Okay, I can no longer divide anything by 2, so I'm going to divide by 3. 5 cannot, so stays at 5. 15 divided by 3 is 5. 3 divided by 3 is 1. Hey, done with that. 3 divided by 3 is 1. Hey, done with that. And now the next number I can divide by is 5. 1, hey, 1, hey. So that's it. Now all I gotta do is multiply these numbers, and that's my common denominator. 2 times 2 is 4. Times 3 is 12. Times 5 is 60. 60 is my common denominator. Okay? Good? Awesome. So 60 is my common denominator. That means that I'm going to multiply the whole thing by 60 over 1, if you want to call it like that, or just 60. Hopefully you understand. And remember, I don't want to be multiplying by the top. Look, 60 times 2 is 120. 120 divided by 12 is 10. But I can just do the following. Okay, because it's easy. 60 divided by 12 is 5. Times 2 is 10. So we got 10x. Okay, 60 divided by 3 is 20. 20 times 4 is 80. Okay. 60 divided by 15 is 4. Times 4 is 16. X, of course. 60 divided by 5 is 12. Times 1, 12. So I get this. Okay. Now the next, fractions, yes. Now, like terms on the same side, no. Variables on both sides, yes. So let's get rid of the lesser one. Do I have additive inverse? Yes. So let me get rid of it. Okay, let's see. Oh, am I correct? Negative 68, yes, I'm correct. Okay. Now, I'm going to divide by 6 on both sides. X becomes negative 68, okay, over 6. Now, what is this? Well, let's put this x over here just in case. Oh, you know what? Let me write it over here. X is equal to, or estimate of, right, negative 11.333. Where do I get that? When you divide negative 68 by 6. So then, where do I find that in my choices? Choice number 4. Gucci? Oh, okay. Let's move on to the next problem. Whew. My God. Okay, problem number 56. Well, on my count. Could be a different number. So please read the problem before we can start. Alright, we got it. Alright, so Donna wants to make a trail mix made up of almonds, walnuts, and raisins. She wants to mix 1 part of almonds, 2 parts of walnuts, and 3 parts of raisins. Almonds cost $12 per pound, walnuts cost $9 per pound, and raisins cost $5 per pound. Donna has $15 to spend. Oh, okay, so that's important information. $15 to spend. Alright. On the trail mix. Determine how many pounds of trail mix she can make. Ooh, only an algebraic solution can receive full credit. Man, these people are crazy. So what do I know? All right, she wants to mix 1 part of almonds. So we have 1 part of almonds. It doesn't say what letter to use. So 1x is going to represent the almonds. I'm just saying, right? 2 parts of walnuts. So walnuts, she wants to mix 2 parts. Okay. And she wants to mix 3 parts of raisins. Okay, so raisins, 3 parts of raisins. Okay. Okay. Now, the almonds cost $12. So now I know that this thing costs $12. Right? Per pound. Walnuts cost $9 per pound. Again, same pound. And raisins cost $5 per pound. Okay? She has $15 to spend on a mix, blah, blah, blah. How many pounds can she make? All right, let's think about it. What do we have here? We got the money and how much she wants to mix, the money, how much she wants to mix, the money and how much she wants to mix to the parts. So I'm gonna set up my equation. 12x, that will be the almonds, okay, $12 per 1 part, plus 18x, okay, plus 15, $5 times the 3 parts, should not exceed. So we're gonna say equals, but in reality this amount, she has $15, this amount should not exceed, okay, so it should be less than or equal to the $15. Okay. So let's add the like terms. 12 plus 18, okay, plus 15. Now this is gonna give you, I could actually just set it up as an equation. Why? But it's gonna give me an exact value. But in reality, remember, you cannot exceed the amount of money that you have. X is 1/3. Okay, X represents the number of parts. So, determine how many pounds of trail mix she can make. Okay, 1/3 of a pound of trail mix. Got it? Because remember something, she went to buy, it's $12 for this, $9 for this, $5 for this. The whole thing is now $45. All right? She only has $15. So $45 per 1 pound of the whole thing. I don't think so. So then when you solve the equation, you find that the number of pounds that you can make is, okay, 1/3. All right, let's move on to the next question. John has 4 more nickels than dimes. All right, in his pocket for a total of $1.25. I get it. Now, which equation could be used to determine the number of dimes X in his pocket? What do I know about the number of dimes? Well, no, I know something about the number of nickels. That he has 4 more nickels than dimes. So the nickels, he has 4 more nickels than dimes. So we have the number of dimes, right? 4 more nickels than dimes. Oh my god, oh my god, oh my god, oh my god, oh my god. I get it. The number of nickels is gonna be 0.05. That's what a nickel is valued. And remember that he has 4 more nickels than dimes. So the nickels, 5 cents, and he's gonna have 4 more than that. And now, how do I represent the dimes? Remember that they say X represents the dimes. So a dime is equal to 10 cents. See that? X plus 4 is the number of nickels. 4 more. X is just the number of dimes. That's what they say in terms of dimes. I hope you understand this. So now, between the nickels and the dimes, he has $1.25. So all I have to do is add them up. So then which of these equations could actually be used to model that? Well, this one says that you have 4 more dimes than nickels. See, it's going to increase. This one says that you have 4 more nickels than dimes. Oh, wait, that's the answer. Oh, here I have no idea. It says that you have 4 times more dimes than nickels. And this one says you have 4 times more nickels than the dime. So it doesn't make any sense. So this is the right choice for this question. All right, let's move on to the next question. Kendall bought X boxes of cookies to bring to a party. Each box contains 12 cookies. She decides to keep 2 boxes for herself. Ah, there you go. You're trying to steal money. She brings 60 cookies to the party. Which equation can be used to find the number of boxes X Kendall bought? Well, think of it this way. Let's see how we can solve this problem, because it's confusing the living bejesus out of me. Kendall bought X boxes. All right. X boxes to bring to a party. Each box contains 12 cookies. Oh, okay. 12 cookies per box. She decides to keep 2 boxes to herself. Okay, so 2 boxes. 2 boxes will be, let me see, if I do 2 boxes, let me just empirically go, theoretically, 2 boxes, 2x. Okay? Wait, hold on a second. 2x. 2x is not 2 boxes. Each box contains 12 cookies. So I'm saying that each box contains 2 cookies. No, okay. So if I cannot have a value like that, then I'm gonna say that 2 boxes will be 24 cookies. Okay, since I cannot represent it with anything else. She decides to keep 2 boxes. Okay. She brings 60 cookies to the party. Which equations can be used to find the number of boxes Kendall bought? Well, 60 cookies. 60 cookies is the same thing as 5 boxes. I hope you understand this much. Now, let's take a look at our choices, now that we have some understanding of what's going on. You see, always write down the information, try to analyze the problem, and then look at the choices, or do backwards, it doesn't matter. All right, 2x minus 12 equals 60. This one says, each box has 2 cookies, and I took 12. And I got 60. Makes no freaking sense. This one says, I have 12 cookies per box. Yes. And I took 2 cookies. Look, cookies. I took 2 cookies. That's 60. Nope. I have 12 cookies per box. And I took 2 boxes, because 24 is 12 times 2. 2 boxes. Oh, okay. Now the last one. I took 24, no, I have 24 cookies and I took away 12 boxes. Oh, okay, don't make no sense. So correct answer is choice number 3. I hope it made sense. All right. Now, if I was to actually solve the equation, I would get, let me see, 60 plus 24 is 84. Okay, 84 divided by 12. 7. Yes, that makes sense. Okay. I'm sorry, you didn't have to do that. I just wanted to analyze what's going on. So in reality, she had 7 boxes. She bought only 5 boxes to the party. So next question. Sorry. All right. A gardener is planting 2 types of trees. Tree mound. Yeah. Type A is a tree. What? Type A is 3 feet tall and grows at a rate of 15 inches per year. Okay. Whatever. Type B is 4 feet tall and grows at a rate of 10 inches per year. Okay, so let's see. Algebraically determine exactly how many years it will take for these trees to be at the same height. Okay, so where would they be the same? How am I gonna solve this problem? But let's see. The same height, planning, feet tall, but it grows at inches. I'm gonna have to change feet to inches. What do I know? That 1 foot, okay, equals 12 inches. This is not something you come up, right away. You need to practice, you need to be exposed to this. All right, so what do I know? That is 3 feet tall, okay, 3 feet tall, so that's 36, right? 36, okay, inches, and grows at a rate of 15 inches per year. So it grows, okay, at a rate of 15 inches per year. That's what I have. All right. What else do I know? That the other one, okay, is 4 feet tall. Okay, this is A. The other one is 4 feet tall and grows at a rate of 10 inches per year. So 4 feet tall, that will be 48 plus 10 inches per year, 10x. Okay, so that's for type B. Where would they be the same? Well, there are different ways of doing this. Let me see. It doesn't say anything about only an algebraic solution will be permitted, so I'm gonna go ahead and I'm gonna do both. Okay, we want to know where would the trees, where A will be the same height as B. That's basically what they want. So let me rewrite this. Instead of writing 36 plus, it doesn't matter. So let me rewrite this as a system of equations. So I'm going to basically, where would A be the same as B? Where would 36 plus 15x be the same as 48 plus 10x? That's basically what it's saying. I hope you understood. We did a video on how to solve system of equations by substitution, elimination, and graphing. So if you don't understand this, then go back to that video. All right. So now, system of equations, it turns into a regular equation. Rules. Distributive property, no fractions, no like terms, no variables on both sides. Yes, get rid of the lesser one. Okay, now additive inverse of 36. So what's 48 minus 36? 12. So 5x. You don't expect me to do minus 36 and minus 36 on both sides, right? We're done with that. And now, what? Not 48, 12. Okay? And now, we divide by 5 and we get x equals 2.4. Okay? 2.4. So, it will take 2.4 years for these trees to be exactly the same height. A parking garage charges a base rate of $3.50 for up to 2 hours. Okay. And an hourly rate for each additional hour The sign below gives the prices for up to 5 hours of parking. So, which linear equation can be used to find x, the additional hourly parking rate? First of all, let's take a look at our rate of change. Okay, from 2 to 3 is 1, from 3 to 4 is 1, okay, 4 to 5 is 1. Now 350 to 9, what is the change? It increased by how much? By $5.50. Okay, from 9 to 4 to 14.50. Well, let's see. It increased by $5.50. From 14.50 to 20, it increased by $5.50. So what I'm gonna do is the following. From 2 hours to 3 hours is 1, right? From 3 hours to 4 hours is 1. From 4 hours to 5 hours is 1 hour. And look at the change for every hour. 350 to 9, it increases by $5.50. From 9 to 14.50, it increases by $5.50. From 14.50 to $20, it increases by $5.50. So basically, it increases by an amount X of $5.50. So if I was to solve for X in any of this, I should get, okay, I should get $5.50. So let's see. If I was to solve this for X, I will subtract 9 from both sides. So 20 minus 9, it's 11. Divided by 3 is now going to be $5.50. This one, 20 minus 9, okay, we're subtracting 9 from both sides. That's what I mean. We're solving for X, remember? So that's 11. Divided by 350, that's not going to be $5.50. Now, here, 1450, if I subtract 350 from both sides, I'm going to get 11. 11, and then I'm going to divide by 2. 11 divided by 2 is $5.50. Okay? Here, I subtract 9, and this thing is going to be like $5.50. Divided by 2 is not going to give me $5.50. I hope it makes sense. So the only one is here. And let's see, if I plug in $5.50 in here, I get 11. 11 plus 350 is 1450. So it checks. Because remember something, X does not represent the hours. It represents the hourly rate. How much it increases per hour. Alright? Cool then. So let's move on to the next problem. Okay, I can barely see, but doesn't matter. So let's read this problem. Sandy programmed a website's checkout process with an equation to calculate the amount customers will be charged when they download songs. The website offers a discount. Okay, if one song is bought at the full price of $129, then each additional song is 99 cents. Okay. State an equation that represents the cost C when S songs are downloaded. Oh my God, cost C, S songs are downloaded. Sandy figured that she would charge $52.70 for 52 songs. Is this the correct amount? Justify your answer. All right. So I need to write an equation, right? Based on the cost. So I'm gonna say cost. What do I know? That she will charge, okay, $1.29, okay, if the song is full price. So regardless, okay, you will get a discount when you buy your first song, and the full price is $129. So if you want it, it's gonna be $1.29. Then each additional song is gonna be at a discount. So 99 cents is gonna be the amount per each additional song. But remember something, per song, I'm not gonna put X in here. Or maybe I should put X. Let's see. S. It should be S. We're gonna try this the first way. I'm not sure if this is correct. So that will be the cost, I think. Now let's see if it works. If 0 songs are bought, then I have to pay $1.29. No, doesn't work like that. If 1 song is purchased, am I gonna pay $1.29 plus the 99 cents? No. So then how am I gonna fix this? How about this way? How about I do this? Alright, so we had a little interruption, but let's pick up where we left off. Alright, so if I put S plus 1, song plus 1, let's see. If I buy 1 song, alright, then I should only have to pay $1.29. So if I put S being 1, 1 plus 1 is 2, 2 times this is $1.98. Nope, I'm gonna end up paying more. So then, how about if I try this? How about if I try subtraction? Let's see what happens. If S is 1, right? 1 song. If I buy 1 song, I should only pay $1.29. So S is 1. So 1 minus 1 is 0. 0 times this is 0. Oh wow, look at this. I end up paying $1.29. That's nice. Then how about if I buy 2 songs? Then 2 minus 1 is 1. So I'm gonna end up paying $1.29 plus 99 cents times 1, the extra 1. So that's 99. So then it actually works. So then this would be the equation, okay? This would be the equation that I would need for the cost. Now let's see if everything that it says is true. So Sandy figured out that she would charge $52.77 for 52 songs. So is this the correct amount? Justify your answer. So all I gotta do is substitute. So $1.29 plus the 99 cents times the 52 songs that I'm gonna buy, taking away, okay, the 52 songs that I'm gonna buy, taking away the 1 song that I pay full price for, right? So that should give me the amount. So then this becomes a 51. So let's use our calculator to figure that out. Okay, oh, but it is low. Wow. So $1.29, okay, plus 99 cents times 51. Or if you want, you could put 52 minus 1 in there, and that's it. So I get an amount of $51.78. So this should equal, this is equal to $51.78. All right, so now we just did the algebraic work, and now justify in words. Well, no, because the amount charged would be $51.78. So that's basically your explanation. All right, let's move on to the next example.